Welcome everybody to our presentation on slope green roof applications. My name is Richard Hayden and I'm the Garden Roof Department Manager here at American Hydrotech located in Chicago, Illinois. Many of you know of American Hydrotech as the leader in providing the highest quality roofing materials for their project around the United States and across the world. In 1996, American Hydrotech introduced to the United States the Garden Roof Assembly. And this assembly includes everything, including the membrane, all the way up through and including the plants. And since that time, we've installed more than 1,400 different projects, and those projects represent more than 7 million square feet of installations. Now, this particular presentation is going to look at just a very small handful of those projects, and those projects are related to sloped green roofs. And you would expect that sloped green roofs create a special set of challenges related to keeping the media on the roof and the plants on the roof. A number of architects, however, have used those challenges as design opportunities, and those opportunities have led them to be able to enhance their project. And we're going to be taking a look at some of those projects in the next few minutes. So sit back and enjoy the presentation. Green roofs have been around for thousands of years and continue to be integral parts of shelters around the world. They started out as parts of shelters of opportunity, using whatever they could find from caves, earthen structures, and the like. As mankind developed tools, he began to develop the architecture that best suited his environment. Sod was a very common roofing material. Thatch roofs using native vegetation materials gave way to roofs using shingles made of wood, clay, stone, and other materials that are still in use today. With some rare but notable exceptions like churches, most roofs covered small spans that were used primarily for residential shelters. We've all heard of the sod farmers of the American prairie. They use sod for the walls and roofs of their homes. Scandinavians have used sod for centuries. This is a picture of the goats on the roof of one of my favorite restaurants in Door County, Wisconsin. When the Industrial Revolution came, roofs became larger and spans became much greater in order to accommodate large industrial and commercial spaces. These structural engineering and roofing technologies gave us the potential to build very large structures with large open floor plans to accommodate all kinds of uses like factories, arenas, and the exhibition halls like the McCormick Place complex here on the lakefront in Chicago. Some of these open floor plans that are created can be spectacular. On the other hand, this technology also gave us, for better or for worse, all the big boxes that dot our landscape here in the 21st century. And many of these big boxes have left us with lots of empty and hard-to-fill retail spaces. Architects have used roofs and their unique features for centuries, but in the past 100 years or so, the move toward a less is more design ethic created more buildings with flat roofs than any other type. There are a number of very striking examples where flat roofs have been used in significant design expressions. Roofs are also subject to budget issues, just like any other building component. For a given area to cover, it is generally less expensive to construct a flat roof than a non-flat roof, such as a hip roof. Fortunately, roofs have also been relied on to become dramatic main design expressions of the building. And Frank Gehry's expressions where roof and vertical facades are melded can be breathtaking. All of us are keenly aware that computers have touched all of our lives in the past 20 years or so. Continuing advancements in software have allowed for very creative efforts in the design of roofs and other building elements. Some of these building elements are derived directly from some very complicated mathematical formulas and geometric shapes. Some building expressions have used fabric dynamics to create some very original buildings. Today, there is a push to incorporate green elements into building architecture and site design. Green infrastructure is a relatively new term that encompasses a wide and diverse collection of features related to clean air, water, and land. Green roofs are a part of green infrastructure and have been recognized by many municipalities and agencies as a very valuable tool in stormwater management. Today, most large-scale roofs are constructed flat. It is the most economical way to cover large spaces in a building. And by default, most green roofs are also constructed on flat roofs. But an increasing number of very creative architects are blending green elements and roof elements in unique combinations, and that's what we're going to be exploring in this presentation. Moving from a flat roof to a slope roof would seem rather straightforward. However, there are a number of critical issues at play. Most important is the relationship of the media and its underlying systems to the waterproofing and the deck that supports it. Below a certain slope, most typical green roof systems can rely on gravity and friction between the roof elements and the green roof elements to keep them in place. Once a certain slope is exceeded, gravity, however, can overcome these frictional forces and the green roof can slide. Depending on the situation and the green roof system, this point where gravity overcomes friction occurs in slopes between 2 and 12 and 3 and 12. For slopes beyond that point, a stabilization method is needed to keep the various green roof components on the roof and not sliding down to the eaves and potentially off the roof. In our industry, there are a number of methods available. At Hydrotech, we developed a product that is mechanically secured to the upper portion of the roof and contains and stabilizes the green roof media and the plants. We call this product GuardNet. Because of the forces at work in slope roofs, we engage a structural engineer to determine the connection loads for all of our GuardNet projects. This engineer takes the information from the designer and determines the potential loadings on the connections that would be needed to secure GuardNet to the roof. The design architect then takes that loading information and his team designs the actual connections and puts them in his plans. Here the GuardNet is being prepared before installation on a roof. As the GuardNet is being installed, dimensions on the cells are being checked to be sure that the installation is proper. Once the GuardNet is secured to the building, the cells are filled with media and a wide variety of plant materials can be installed. In the images that follow, I'm going to show you examples of how we help designers on these projects accommodate all different roof shapes with this particular product. Moving from a relatively flat roof to a slope roof is shown here at Lace Elementary School. This school is in a suburb of Chicago. This project involved the construction of a new addition to Lace Elementary School with a sloping green roof that was secured with GuardNet. Here the roofers are preparing the roof after finishing the waterproofing and installing the insulation and root barrier. The GuardNet system is attached to the roof ridge with a series of steel cables that keep the system securely attached to the roof. Here the roofers are finishing the installation of the root barrier in advance of installing the GuardNet. The GuardNet system keeps the media in place and is supported using steel cables. Here the roofers are inspecting a section of GuardNet prior to installation on the roof. And this is the result of the final installation. In this instance, a sedum carpet was installed on the media-filled GuardNet system. Here we move from one Chicago suburb to another. This is the Tyner Interpretive Center in north suburban Glenview, Illinois. This is a nature center set in the midst of a restored prairie wetland, and it is devoted to the study of ecology of the area. Here the architect took what could have been a very simple slope roof and added a curved surface, which works very well with the GuardNet. On the left-hand side of the building roof, there is a section of photovoltaic solar tiles that are built into the roof. We'll see more on that shortly. This image shows the end view of the building and the curved profile of the roof plane. The architect used a post and beam type of construction where the compound posts support the curved glulam beams that formed the base of the structure. This is a photo taken during construction showing the basic post and beam arrangement and the roof deck that's being formed. Once the deck and waterproofing were installed, the GuardNet system was installed. Here the roofers are adjusting the GuardNet prior to adding an adjacent section. The GuardNet system comes in a wide range of thicknesses, starting at 3 inches and going on up. This is a 6-inch deep GuardNet used at the Tyner Center, and this thickness allows a wider range of planting options, including plugs and larger plants, as well as sedum carpet. In this photo you can see the GuardNet after completion of the installation. There's a space between the GuardNet and the edge of the roofing where the ballasted vegetation-free zone will be installed. Here's a view of the junction between the GuardNet portion of the project and the adjacent solar tile section of the roof. There will be a ballasted vegetation-free zone between the parapet and the metal edging. Once the GuardNet is in place, the media is installed starting at the top of the slope. Starting at the top helps ensure that the GuardNet material maintains its shape and configuration throughout the roof surface. As the media is spread out, it's leveled and compacted. And it is compacted using a hand tamper. You can see one in the background of this particular photograph. Here's another view of the roof from the ground, showing the roof near the completion of the media installation of the project. Now we're on to the installation of the landscape materials. Prior to the installation of the plugs, an erosion control matting is installed over the media and secured to the edges and periodically within the interior of the matting. The plugs were lifted to the surface and arranged for easy access by the landscape crews. And here the crews are busy planting the plugs through the erosion control matting. A wide variety of plug-sized materials were used on this particular roof. This installation was completed in 2006. Here's a better view of the solar voltaic tiles that were incorporated into 1/3 of the total roof area. Solar elements will become more and more common on green roofs, and many of us have seen the solar panels that are raised up off the roof and on our own separate supporting stands. Here the architect incorporated the solar elements into the curved roof plane in the same way as the green roof elements. And here's the roof in the summer of 2011. The roof truly blends this building into the surrounding naturalized area, and the curve the architect used definitely adds a bit of flair to what could have been a fairly standard sloped roof. We're leaving Chicago and heading off to the west coast of the United States for this particular project. This is the H2 Hotel in Healdsburg, California. This project illustrates a green roof with a very complicated, undulating, and wave-like roof profile. The garden-net system is an ideal method for accommodating the compound waveforms of this particular roof. Its flexibility moves with changes in the roof profile, and it is easily cut to fit around skylights, hatches, and other common roof features. Here the workers are filling the garden-net system with green roof media. The workers need to make sure that the garden-net system properly conformed to the roof profile during installation of the media. And this is the finished installation after several months of growth. The green roof truly reflects the H2 Hotel namesake. So now we travel to Washington, D.C. and the rooftop of the national headquarters of the American Society of Landscape Architects. This green roof created a three-dimensional feature on the roof using a very steep and curved green roof. This green roof was also used to hide air conditioning units and other mechanical equipment that you'd find on a roof. Here the steel framework and deck for the green roof has been completed, and workers are busy installing waterproofing, root barriers, and the garden-net system. As you can see, this is a very crowded roof construction site. The workers are installing the garden-net system and attaching the supporting cables to the top of the slope. Here the media has been installed and a layer of moisture matting has been installed to provide additional water storage capacity to the soil cross-section. Additional media will be installed on top of this matting to match the height of the curved steel edging shown on the left. Once the media is in place, plugs were planted through an erosion control matting that is designed to keep both the soil and plants in place. And here is one half of the new green roof after a number of months. And like many things, this green roof continues to get better with age. From Washington, D.C., we travel to South Boston and the McAllen building. This building features a cascading green roof on the sloped upper face of this residential building. This building is highly visible, and the terraces created on the top of this building have spectacular views of this portion of South Boston. Here we see the garden-net system on one of the terrace green roofs. It is being prepared for attachment to the roof. Many garden-net applications like this one require multiple garden-net units connected together to cover the entire area. And in this image, the workers are adjusting the alignment of the garden-net. Once the garden-net is in place, the workers begin installing the media and the ballast stone for the vegetation-free zones that are around the green roof perimeters. Here the planting media installation is complete and the area to the right is ready to receive ballast stone. This roof was planted using sedum plugs. The plugs were installed through an erosion control blanket that keeps the plants and media in place until the plants get established. And here's the roof after a number of months of good plant growth. And this is the overall view of the top of the McAllen building, showing the cascading green roofs that flank the terrace areas. From Boston, we travel to British Columbia and to the Vancouver Convention Center. As the first LEED Gold certified convention center, this building has an enormous green roof with a faceted set of slopes. We're going to highlight the very steep green roof that was installed at this building. Much of the roof at the Vancouver Convention Center is gently sloped. The areas between the convention center and the seaplane port have a walkway with green roofs of varying slopes. This is the area that we'll be looking at. Some of these slopes, as shown in the distance on the right, become very steep. So steep are these proposed slopes that a mock-up of the system was created to test the GuardNet system with the proposed plantings. Here a worker is securing root barrier in the mock-up container. GuardNet was installed into the mock-up container. The mock-up containers were filled with media and planted with an assortment of perennials that included these ornamental grasses. As you can see, the grasses in the mock-up really seem to like this condition. And here's the actual installation showing the GuardNet and planting in progress. In this project, the plants were larger 1-gallon container plants that were planted into the cells of the GuardNet. Additional media was added after the plantings were completed. In this portion of the walkway, the slope is between 10 and 12 and 12 and 12, and the slope formed the base for these sculptural elements. Here is the end of the green roof where the slope has increased to 81 degrees, near vertical. This project shows the extremes to which GuardNet can secure green roofs to the top of a roof. For our final project, we're jetting back to New York, to the newly renovated Lincoln Center Plaza. Located in New York City, Lincoln Center was one of the world's most important performing arts centers and is the home of the Metropolitan Opera, the New York City Ballet, the New York Philharmonic Orchestra, and the Juilliard School. This project was designed by Liz Diller of the firm Diller, Scorfidio, and Renfro, and their team of engineers from FX FAL and turfgrass experts from Cornell University. A number of the graphics in this particular part of the presentation come from Liz Diller and her firm. The project is located on the north side of the renovated plaza and flanks the renovated reflecting pool as shown in this image. The overall dimensions of the green roof are 148 feet by 73 feet and forms the roof for a coffee shop and retail space for the area. The shape of the roof is technically defined as a hyperbolic paraboloid. It is the blend of several curved mathematical shapes. The structure started off as a steel framework that set and defined the overall shape of the structure. Here the understructure is shown. This understructure space would eventually become the retail space for the development. The deck structure was covered in metal panwork to support concrete pours that would come next. And this is a view of the top of the shell after the concrete layer was installed on top of the steel framework and the pans. This image shows the steep nature of this project. The workers are installing root barriers and insulation, and the angle shapes in the foreground and to the left are supports for the hand railing system. Here the workers are assembling parts of the GuardNet system. This is a view down the slope. The GuardNet system accommodates protrusions, like these handrail supports and other items, very easily. In this image, the GuardNet was completed and the media was installed, and the initial shape of the green roof was becoming apparent. Sod was installed over the top of the installed media. At the base of the green roof, a set of stone step terraces was installed. These terraces would be covered in sod when completed. In the foreground, you can see the black irrigation pipes and sprinkler heads ready for installation. Here's the finished steps and lawn areas. A clear glass railing was installed along several edges of the lawn area. And here's a view down the slope after installation of the sod. And this is a view of one of the opening day festivities. Adjacent parts of the site still weren't finished at the time the lawn was open. This space is proving to be a very popular and inviting public space in New York. And here's the lawn as it looks from the main Lincoln Center Plaza level. The protection boards on the left and right-hand side of the lawn area have subsequently been removed. Well, this concludes our presentation, and we hope that this presentation has provided some design ideas and some inspiration to the architects and landscape architects and designers that are in our audience. We hope that this presentation has been able to show that roofs and green components can be combined in some very unique and creative ways. It's limited only by your imagination. Thanks for watching.